G'day, Lance from Motive Power back again. And this episode, well, now you've got the vehicle moving, because we've done the engine, the transmission and so forth, how do you know where it's going to move to? So this episode is about steering. So, as usual, this is not advice, it's just merely guidance for your further review. And as usual, we're going to start with some terminology about steering. And we'll see a little bit more as we go through. So there are generally 4 modes of steering that are somewhat commonly used. In your car, for example, it's 2-wheel steer, front 2-wheel. But many vehicles also have rear 2-wheel steer, or what's called 4-wheel coordinated steer, where the wheels turn in opposite directions to get a very tight turning circle. And then there's crab steer, where they all turn in the same direction so the vehicle moves along but also sideways at the same time. We'll talk more about all of that in a moment. But there's the 4 major steering modes that we can talk about. Not always used, not always recommended to put on the vehicle, because sometimes people get confused as to where they are, what they're doing, and what mode they're in. All right. So let's just quickly do some examples. You may be familiar with the M1070 heavy equipment transporter. Various versions of it used around the world, but it has front wheel steer, as you would expect with any truck. It also has the 4th axle steering in what is essentially a 4-wheel steer mode to tighten up the corners. So readily available, often done in this sort of application. So that's a quick overview of where individual wheels, tyres are steered. But there are other ways of doing it. And one of those ways is articulation of the vehicle. Let's have a quick look at a Ventrac. This is a plan view of a Ventrac tractor, 4500. And you'll see there's a bend in the vehicle. It's articulated. Now that means that this axle here is a rigid non-steering axle, and as is the back, rigid non-steering axle. Removes the requirement for CVs and lots of other things. And in this case, blended into the steering or the joint is also the roll articulation, so that it acts as suspension. That tractor is a single articulation unit. But things like graders can often have 2 articulation joints, and that lets them do somewhat weird things. A double articulated grader can drive along the road with its rear wheels on the road, but its front wheels up on a bank on a completely different plane, so that the blade is actually grading the embankment. Crazy things like that, but again, often done. This is a Sterling T26, experimental US military truck from the 50s, I think. Slow speed, heavy load carrier. But if you look carefully, you'll see that the front bogie is steered. not the individual axles. Again, simple drive axles, non-steering, but put on a bogie frame that can steer. And that's typically called wagon steering. It does have uses today, but generally speaking, vehicles run at higher speeds than would be permissible with this sort of application on a truck. We don't see it much in Australia, although it is coming, but a lot of semi-trailer trailers have rear steer, and we'll show you an example. Here's what this company has called rod steering, and they're using the pivoting around the kingpin to control the steering of the rear axle. Now that's essentially wagon steering, and that's a simple, basic arrangement that helps a whole semi-trailer move more manoeuvrably. Of course, there are more complex arrangements building up to things like this, like made by people like Cometto and Nicholas, as well as TRT, but multi-axles, perhaps individually controlled. When you get to that stage, you can make it do all sorts of things, like turn on the spot. That would be typically a driven wheel, and that means the unit would probably not have a haulage vehicle on it. So let's head to the whiteboard to explain some of these terms a little more. So let's draw a simple vehicle and see if we can describe better some of these steering characteristics. Simple four-wheel vehicle going straight ahead. Let's say that's the front. So turning a corner, that would be two-wheel steer. You might say it's front two-wheel steer. But something like this is rear two-wheel steer. And if you think that's unusual, look at a forklift. They're nearly all like that. Now we're starting to get complicated. That's four-wheel steer. So the vehicle turns as tightly as possible. And one last one. That, my friends, is crab steering, where the vehicle is moving. It's actually going forward and sideways at the same time. Are all these needed? Yes, depending on your application. So let's look at steering in a little more detail. We'll look at some of the geometry. Let's just say we've got our two-wheel, our four-wheel vehicle with two-wheel steering. What you really want to do, I can project that line there, I can project a perpendicular there, and a perpendicular here. They all meet at one point. That's your turning point. What it means is there's no scrub on any of the tyres, and everything's happy making the turn. This is called equirpemnt steering. I assume there was a Mr. Ackerman at some point. Now the detail of this is that this wheel has turned further than this wheel, has steered further than the outer wheel. That's the only way the geometry works. So to exaggerate that, we might have an outer wheel, and we'll have an inner wheel. And there's this distinct difference. In fact, if I was to draw an axle, I'll put a a wheel here and a wheel here. And if I put the steering links in, you'll see them look something like that. That arrangement is to get Ackerman steering. Is everything Ackerman steering? No, but nearly everything. I'm not even sure I can draw this, but apparently on race cars, it's common to have what's called anti-Ackerman. Where the outside wheel turns tighter than the inside. The opposite of Ackerman and therefore called anti-Ackerman. That's really only appropriate where the inside tyre is all but useless. So a high performance car cornering hard with no weight on that tyre. So if you're in that situation, anti-Ackerman is appropriate, but I would suggest to you that normal off-highway vehicles are just Ackerman. So you may recall that I said with Ackerman steering, the inside wheel moves the furthest. And that's good for two-wheel and four-wheel steering. When we get to crab steering, it's complicated. I'm exaggerating it, but this is what, it's just inside, so that's got to go. So I'm struggling to get it right here. You're going to face a situation like that, where the Ackerman on the axles has led you to a situation when it's used in crab that these wheels are not in alignment. That's the reason crab steer should only be used as a slow speed, occasional thing. If you're on hard stand, less of an issue if you're on dirt where your tyres can spin a little bit. So be aware of that with crab steer. Brakes and steering often don't mix. I'm going to draw a rough axle here, kingpin, hub. Somewhere here we've got a steering link. Particularly on bigger vehicles, particularly with larger tyres, the distance from the kingpin to the centre of the tyre can be considerable. Now the wheels usually have an offset, so the tyres are brought back into the vehicle, but you still get an offset. So if that vehicle is just stationary there and you choose to steer it, what will happen is that this tyre will move like that, this tyre will move like that. They'll go around the kingpins, but they'll also move the vehicle because the contact patch on the ground has changed. You're generating a torque around this pin in order to steer the vehicle. That's probably obvious. The size of the torque is dependent upon that offset. Now what happens, particularly if you've got a four-wheel drive vehicle that might have park brakes on all axles, and will almost certainly have service brakes on all axles. If you've got your brakes fully on, you can't steer. And you are generating massive forces in your steering system by trying to, because this wheel will not roll. So how do I get it to turn around that pivot point? It's a case of whether your steering effort is greater than your traction. It's the reason in your car when you're perhaps pulling out of a tight parking spot and you need to steer quickly, you can't do it with your brakes full on. You might still have a little bit of brake, but not full on. So you build a vehicle, put the brakes on, and you realize it won't steer. Don't be surprised. That's the reason. So most off-highway vehicles are hydraulically steered. And the control of that is through what I call a Charlene valve. This is a Charlene valve, a very simple picture of it. Normally there would be a steering column and a steering wheel plugged into this spline. Hydraulic lines in, hydraulic lines out. It's a Garola type pump, but it's manually powered, and it's metering oil from your supply to your steering cylinder, therefore controlling the steering. It's a really simple way of controlling your steering, and there's no direct mechanical connection to your steering wheels or your steered wheels. That of course can create some issues, particularly if you lose hydraulic power, you've lost steering. Typically hydraulically driven steered vehicles give priority to steering before anything else, but you can still lose a hose or a pump. So a lot of vehicles have emergency steering systems. Aircraft towing tractors is one. If you've got a multi-million dollar aircraft on behind and your steering fails, you really don't want to lose control. And you can't stomp on the brakes real quick because you'll break the nose gear off. So 3 systems I'm aware of: wheel driven, hit a button, out pops a little hydraulic pump with a wheel, rubs on the tyre of the tractor, and as the vehicle is still rolling, that pump is generating enough fluid to control your steering. But of course, if you've lost a hose to the steer cylinder, you're still going to be in trouble. Other options: hit a button and have an electric pump come in and do the same thing, or an accumulator. You're only looking for enough fluid flow until the vehicle can be stopped safely, not for a long distance. Accumulators are good for that, but they're not so good when you want to tow the vehicle back to the workshop. That's where battery powered systems are better, but of course you can flatten the battery. And wheel driven systems, well, they'll just keep going anyway, providing you haven't blown one of those key hoses. The general assumption is that big vehicles can't be steered mechanically, and that's partially right. Obviously it's a question of scale, but there are options for mechanical steering for larger vehicles, and they come with power assisted options. The advantage of mechanical steering is you don't need an emergency steering system. Okay, the steering effort's going to increase, but everything is still there, connected, installed and operating. You just lost your power assist. So let's look at a couple of power assist options that there are. This probably looks like a standard, if maybe large, steering box. You have an input here, note the size of the input shaft, and an output shaft here that your steering links would connect to. It's a Shepherd power steering box. The difference with this is that it's power assisted internally, hydraulic power assist. So you can still mechanically steer this unit, but under normal circumstances you've got inbuilt hydraulic power assist. If the power assist fails, you've still got your mechanical connections. Works well. Use them on vehicles up to around 50 ton, and they probably could go bigger again. Another option, and I apologise but this is the only picture I could find, is a Garrison valve. This is actually a steering link. You'll see the tapered pin for the ball joint and so forth to connect to, and it might go back here to the steering box. It's essentially a rigid steering link, but in here, internally, is a hydraulic valve. So that as force is applied to this link, the spool inside it moves and directs flow. So this in itself is a control for hydraulic assist. Again, that hydraulic assist fails, you've still got the mechanical connection. And yes, you can use Garrison valves and shepherd boxes in the same system. So you've got power assist at the steering box, and then you've got power assist through cylinders controlled by the Garrison valve. So a little bit of duplication, but when it comes to steering, it can all be about safety. When you've got multi-axle, let's say 2 axles because it's just easier to talk about it, 4-wheel steering, things can get complicated. If you're following the modes that I expressed earlier, 2-wheel steer, front and rear, 4-wheel steer and crab steer, operators have been known to get very confused as to which one they're in. But it's also possible for the steering system itself to get confused. If you've got, say, a hydraulic steering system connected to the front axle and to the rear axle, how do you keep them aligned? I've seen a whole lot of things done with zero leakage valves and all sorts of things. The key, in my belief, is not to prevent misalignment from happening. And by misalignment, I mean the front axle is not in line with the rear axle when the vehicle is supposed to be going straight ahead. Don't try and stop that misalignment. Don't prevent the error, correct the error. It's much easier to do it. There's some tricks, and I'm not going to put them on the video. Yeah, we've talked about crawlers too. Crawler steering we covered in a prior video, so this one's really about wheeled vehicles. But we need to go into some more detail about articulation. This is a plan view of an articulated vehicle. In this case, again, the Ventrac 4500. It shows a couple of things. It shows the enormous amount of space that's lost within the vehicle because it's articulated. Obviously, you need to leave room for the articulation to happen, and that takes away space that could be used for fuel tanks and so forth. That's a downside of articulation. It does give tighter turning than a normal steered axle. The downside, as I've experienced several times, particularly in mind that this vehicle is designed for very steep slopes, up to 30 degrees, is sliding sideways and getting a tree right there. Once you're up against an obstacle with an articulated vehicle, you're stuffed. Now, I chose not to winch it off, but at least 3 occasions I have got the chainsaw and cut off the sapling that was there and then driven out over the stump. It's a downside of articulated vehicles. If you park hard up against something, you can't get away from it. Because if you turn right with the front half of the vehicle, the back half is turning left and going into the obstacle. And obviously, with a single articulation, you can't do crab steer and drive off it. Now, people will tell you the turning circle of their vehicles. It's often in specifications. But it's normally just put as a figure. It's a 10-meter turning circle. Well, what is that? Is that a radius or a diameter? Is it to the inside, the outside, or maybe the center line? Depending on the application, it might be good to quote curb to curb. So it's really defining the width of the roadway that the vehicle can U-turn in. Or it could be wall to wall, probably more appropriate how close two walls can come before you can't do a U-turn. Don't just quote turning circle. You need to nominate the conditions. Inside, outside, centre, mean, between curbs, between walls. I think that's, radius or diameter. That's one of the key things people forget. So there's an oversight of what steering options are out there and what the systems could possibly include. I would counsel you to keep it as simple as possible. If you can, keep electronics out of it, even if there's a lot of steering functions. Generally speaking, everything can be done mechanical. Articulation, probably needs to be done hydraulically, but a rigid frame vehicle, try and stay mechanical and only add electronics if you have to. Make sure that vehicle can be, or that steering system can be understood and supported in field. It's a long way to go around the world to explain to someone how to fix their steering system. I've come close to having to do that. So keep it simple, and then you can sleep well at night and move on to do the rest of the vehicle.